Hey everyone, and welcome to this explainer. So if you're building applications with machine learning right now, you already know the deal. The landscape is moving incredibly fast. I mean, a model that's considered state-of-the-art on Monday might honestly be old news by Friday. It's wild. So today we're going to look really closely at how you can write clean, highly scalable code when you're using Hugging Face pre-trained models. We really want to make sure that the code you're writing today doesn't turn into a massive, tangled headache for you tomorrow.
Think about it for a second. You've scoured all the available resources, you've run your tests, and you have found the absolute perfect model for your current project. It's fast, it's highly accurate, it's literally exactly what you need. But here's the real question. Is your codebase actually ready to handle it? And more importantly, can your code survive a sudden model upgrade when a much better version inevitably drops next month? Okay, let's dive into this.
All right, Section 1, the Model Hub Magic.
To get these models working properly in our code, we first need to start right at the source, which is the Hugging Face Model Hub. If you haven't used it, it's basically this incredible treasure trove for developers, totally designed to make selecting the right model completely frictionless. Let's walk through a practical workflow here. Step 1, you just need to find a model. So let's say we're looking for a French-based model that can specifically perform mask filling. Step 2, we identify that exact task. And then step 3, we actually load it into our code. Honestly, it's that easy. You search, you select, and you're ready to build. So for our specific requirement, we search the hub and we decide to go with the Camera Bay base checkpoint to try it out. And you know what's crazy? That simple string, just that single identifier right there, is literally all we need to start using this model. We don't have to download massive files manually. We're not writing hundreds of lines of complex configuration code. We just need to know its name.
Moving right along to Section 2, the pipeline approach.
Now that we actually have our checkpoint identifier, how do we bring it into our Python environment? Well, this is by far the easiest, most straightforward method you can use. Bringing it to life takes just a few lines of code. We simply use the pipeline function that's provided by the Hugging Face library. And within that function, we just load our Camera Bay base identifier and we specify the task as fill mask. Loading a model inside a pipeline like this just subtracts away all of the heavy lifting. It gets you up and running super fast. There is a catch, though. You got to be careful because the chosen checkpoint actually has to be suitable for the specific task you're using it for. Loading Camembert base for mask filling works perfectly. But if we try to force that exact same checkpoint into a text classification pipeline, the results you get won't make any sense at all. Why? Because the specific structural head of this model just isn't built for text classification. It's a completely different job. So always make sure you're using the task selector in the Hugging Face Hub interface to pick appropriate checkpoints for your specific needs. Now, what's really interesting about this slide is Section 3, the hard coding trap. So pipelines are fantastic, right? But eventually, you're going to want more granular control, and you might want to bypass them entirely to instantiate the model architecture directly. But listen, this is exactly where things can get super dangerous for the longevity of your code. For our French mask filling model, you might explicitly write Camembert for masked LM right there in your code. This directly calls the specific Camembert class. And yeah, it works. The code will execute. But doing this, it locks you into a very, very rigid structure.
I want you to think really carefully about the implication here. What happens when you want to switch to a completely different model family down the road? Like, what happens next week when a brand new, vastly superior French language model drops, and it is not based on the Camembert architecture? Because you hard-coded Camembert for masked LM, your code is now completely brittle. It literally breaks the second you try to swap in that new state-of-the-art checkpoint. You'd have to manually go back into your code base at, 2 a.m., hunt down every single instance of that specific class and rewrite the whole thing while chugging cold coffee. That is for sure the exact opposite of efficiency.
Which brings us to our hero, Section 4, the Auto Class Advantage. This brings us to the core focus of our explainer today, and frankly, the ultimate best practice for developers. And that is future-proofing your work using auto classes. Auto classes are, by their very design, architecture agnostic. Now, what does that mean? It means your code is designed to function entirely independently of the specific underlying model architecture, allowing for completely frictionless checkpoint swapping. It's basically like a universal adapter. Hard-coding a specific class is like wiring a proprietary charger directly into your living room wall. It only ever charges one type of device. But auto classes, they're like installing a universal USB-C port. Whatever new device comes along, you just plug it in and it works seamlessly. And this brilliantly illustrates that difference. On the left, our previous code severely limits users to checkpoints that are loadable only in the Camembert architecture. But look on the right. By simply replacing it with AutoModel for masked LM, you have instantly made your application architecture agnostic. When that shiny new model drops next week, you don't even have to touch your code's core logic. You literally just change the string of the checkpoint identifier and the auto class automatically figures out the correct architecture to instantiate behind the scenes. It makes switching out checkpoints completely effortless. It's a total game changer.
So the crucial point is Section 5, Essential Model Checking.
While loading and swapping models has been made incredibly easy by using pipelines and these amazing auto classes, your job as the developer isn't quite finished just because the code finally runs. Regardless of how seamlessly you loaded up that checkpoint, you still have to perform some vital reality checks. You absolutely need to investigate how the model was trained, and you really should look into the specific training datasets that were used. You have to understand the model's limits and, critically, its hardware requirements to ensure it's not just going to crash your servers the minute it's under heavy load. Fortunately, all of this essential performance and system info is laid out clearly right there on the model card on the Hugging Face Hub. Remember, efficiency in your coding doesn't excuse a lack of diligence when it comes to deployment.
We've covered a ton of ground today, right? From the absolute simplicity of the Model Hub to the vital necessity of using architecture-agnostic auto classes. So I want to leave you with this final provocative thought. When tomorrow inevitably brings a brand new, highly capable, state-of-the-art model, what exactly will happen to your project? Will your entire codebase require a tedious manual rewrite just because you fell into the hard coding trap? Or will you be able to upgrade your entire application simply by pasting in a single new checkpoint identifier string? By mastering auto classes, the choice is entirely yours. Thanks so much for joining me for this explainer, and hey, happy building out there!